Good morning. Nova here. June 19th, 2026. Happy Thursday, and welcome to your morning AI and IT news. Today's big theme is control. Who controls the chips, the power, the agents, and the data those agents can touch? That question is suddenly everywhere. We're seeing it in cloud policy, AI safety, enterprise coding tools, and even in old-school malware that still finds new ways to make money. So this morning, let's walk through 8 stories that show how the next phase of AI is not just about smarter models. It's about infrastructure, security, and who gets to move first.
Security. Securing the future of AI agents. A new enterprise push around AI agent security is focusing on what some firms are calling an AI control roadmap. The idea is simple. Use traditional controls like identity management, least privilege access, network segmentation, and audit logs, then add real-time monitoring for agent behavior, tool use, and data access. This matters because companies are moving from chatbot pilots to agents that can read tickets, write code, query databases, and trigger workflows. That is a much bigger risk surface. A misconfigured agent can leak data or take expensive actions at machine speed. The practical shift now is from model safety alone to system safety. Companies want policy engines, approval checkpoints, and kill switches before agents touch production systems. Ever heard of least privilege? It means giving software or users only the minimum access needed to do a task. For AI agents, that sharply reduces the damage from mistakes, hijacks, or prompt injection. What to watch next is whether security vendors can standardize agent observability the way cloud monitoring became standard a decade ago.
Semiconductors. Amazon wants to sell Trainium and Inferentia beyond AWS. Amazon is reportedly in talks to sell its in-house AI chips to other data centers, not just through AWS. That would put Trainium for training and Inferentia for inference into more direct competition with Nvidia. AWS CEO Andy Jassy has said the broader custom chip opportunity could be worth around $50 billion. This is a big strategic turn. Amazon already uses these chips internally and through AWS instances, but selling them externally would move it closer to a platform supplier model. That matters because AI demand is still constrained by Nvidia availability, cost, and power use. For customers, more chip options could mean lower prices and better negotiating leverage. For developers, though, the catch is software. Nvidia's CUDA ecosystem is still the default for many AI teams, and switching tools is not trivial. Ever heard of inference? That's when a trained AI model actually answers questions or generates output. Inference usually happens far more often than training, so chip efficiency there can strongly affect cloud costs. Watch for ecosystem moves. If Amazon expands compiler, framework, and model support, this becomes much more serious for Nvidia. Cloud. AI data centers get a faster path to the power grid. The U.S. Federal Energy Regulatory Commission, or FERC, has told grid operators to create a faster interconnection path for large loads, including AI data centers. In plain English, some new facilities may get a government-backed fast lane to connect to the grid. That sounds like a win for cloud expansion, and in the short term, it is. AI infrastructure projects have been delayed by years-long queue times for grid hookups. Faster processing could help hyperscalers and colocation providers build sooner. But the key problem did not disappear. Faster paperwork does not create more electricity. In many regions, generation and transmission are already tight, so this may shift competition from queue delays to actual supply scarcity and pricing pressure. For consumers, that could eventually mean higher utility rebates in fast-growing data center markets. For cloud companies, it increases pressure to pair AI campuses with nuclear, gas, solar, or battery deals. Ever heard of interconnection? It's the process of linking a new power-hungry facility, like a data center, to the electric grid safely, with studies to make sure the system can handle it. What to watch next is whether state regulators and utilities can keep up with federal urgency. LLM. Google introduces Gemma 4 12B as a unified multimodal model. Google has introduced Gemma 412B, a 12 billion parameter multimodal model designed to handle text and images in one unified, encoder-free architecture. Encoder-free means it does not rely on a separate vision encoder bolted onto the language model. Instead, the system is built to process multimodal inputs more natively. Why that matters now is efficiency. Smaller multimodal models are becoming more attractive to developers who want strong performance without the cost and latency of giant frontier systems. A 12B model can be much easier to fine-tune, self-host, or deploy in controlled environments. This also reflects a broader industry trend. Enterprises want models that are capable enough for production, but small enough for privacy, speed, and budget constraints. Ever heard of multimodal? It means an AI model can work across different input types, like text and images, instead of being limited to just one format, such as plain language. Watch for benchmark details, licensing terms, and how well Gemma 412B runs on non-Google hardware. That will shape real adoption.
Developer. Anthropic brings live artifacts to Claude Code enterprise users. Anthropic has added artifacts to Claude Code for team and enterprise plans. The feature turns a coding session into a live, shareable HTML page that updates in real time. Teams can use it for dashboards, app mockups, bug investigations, and visual explanations of code work. The important detail is what it is not. Anthropic is positioning artifacts as a secure, self-contained canvas, not a full hosted app platform. Pages are tightly sandboxed, private by default, and blocked from making external network requests. That sharply reduces data leakage risk. This update matters because it changes how engineers communicate with non-engineers. Instead of sending status updates or screenshots, they can share a live view of the work as the AI agent analyzes code and updates results. It also sharpens competition with OpenAI's Codex sites, which is more like a persistent app hosting environment. Ever heard of sandboxing? It means wanting code inside a restricted environment, so it cannot freely access networks, files, or system resources. It is a core safety tool for enterprise software and AI workflows. Watch whether companies prefer Anthropic's safer, lighter approach or OpenAI's fuller app model.
Security. Microsoft spots a USB spread crypto stealing backdoor. Microsoft says it has discovered a lightweight backdoor called Crypto Clipper that steals cryptocurrency by hijacking wallet addresses. The malware spreads over USB drives and communicates through Tor, the privacy-focused network often used to hide traffic routes. The attack is sneaky but simple. When a victim copies a crypto wallet address, the malware can replace it with an attacker-controlled address before the transaction is sent. If the user does not notice, the funds are gone. This matters because it shows how old attack paths still work. Even in the AI era, removable media, clipboard hijacking, and hidden command channels remain effective. It is also a reminder that crypto theft often relies less on breaking blockchains and more on compromising endpoints. For businesses, USB controls and endpoint monitoring still matter. For consumers, always verify the first and last characters of a wallet address before sending funds. Ever heard of Tor? Tor is a network that routes internet traffic through multiple relays to obscure where it comes from and where it is going, making tracking much harder. Watch for indicators of compromise and whether this evolves beyond crypto theft. AI. OpenAI tests model behavior before launch with deployment simulation. OpenAI has introduced deployment simulation, a method for predicting how a model may behave before release by simulating real deployment conditions using conversation data. The goal is to improve safety evaluations by testing not just benchmark performance, but likely real-world use patterns. That is important because many model failures only appear after launch, when users chain prompts, probe boundaries, or use tools in messy ways that lab tests miss. Simulating deployment could help identify risky behaviors earlier, including overcompliance, deception, harmful advice, or failure under pressure. This also signals a broader maturation in AI safety. The industry is moving from static evals toward environment-aware testing. In other words, not just is the model smart, but what does it actually do when people use it at scale? For enterprises, better pre-release evaluation may reduce surprise regressions and compliance headaches. Ever heard of evaluation? In AI, an evaluation is a structured test used to measure model quality, safety, or reliability. Better evals matter because weak tests can make risky systems look safer than they are. Watch whether rivals adopt similar simulation frameworks.
Semiconductors. ASML disputes U.S. claim about top chip tool in China. A fresh U.S. claim suggested one of ASML's most advanced chip-making tools may be in China. ASML says it is not. The disagreement matters because ASML, based in the Netherlands, is the sole supplier of extreme ultraviolet lithography systems, or EUV tools, used to make the most advanced semiconductors. If an EUV machine were improperly shipped or installed in China, it would be a major export control breach with global consequences. But there is also a strong business argument against that scenario. ASML's export licenses, Western government relationships, and long-term market access are too valuable to risk casually. So why does this matter right now? Because semiconductor policy is increasingly shaped by suspicion, not just proof. Even uncertainty can affect investor sentiment, diplomatic pressure, and customer planning. For the global market, this is another sign that chip supply chains remain deeply geopolitical. Have you heard of lithography? It's the chip-making process that uses light to print incredibly tiny circuit patterns onto silicon wafers. More advanced lithography helps produce faster, denser, and more energy-efficient chips. Watch for follow-up from US and Dutch authorities, not just headlines. Hey, Nova here. So that was the thread today. AI is scaling, but every layer around it is getting more important. Chips, power, access controls, evaluation methods, and plain old endpoint security are all becoming part of the same story. The companies that win this next phase may not just be the ones with the smartest models. They may be the ones that can deliver reliable infrastructure, safe deployment, and tools people across a business can actually use. And if you felt a pattern here, you're right. The AI race is starting to look less like a sprint for novelty and more like a build-out of roads, rules, and operating systems for the real economy. All right, catch me again tomorrow. Have a great day out there.